The sum of an arithmetic progression or a linear sequence is simply the addition of all the terms involved in that particular arithmetic operation or arithmetic progression. Is that okay? So let's write down the general formula for the sum of an arithmetic progression. Let us say, let's sum of an AP be equal to Sn. Then we have that Sn is equal to n over 2 into brackets 2a plus n minus 1d. So this is the formula we can use to obtain the sum of an arithmetic progression. We can also have this in a similar form by saying the sum Sn is equal to n over 2 into brackets a plus last term, where last term is equal to a plus n minus 1d. So we substitute the value of L, which is equal to a plus n minus 1d, into Sn. We have Sn to be equal to n over 2 into a plus n minus 1d. Of course, this is equal to n over 2 into 2a, because a plus a is equal to 2a plus n minus 1d. And that is the same thing we have over here. But in some cases, you might be given the number of terms, the first term and also the last term, to obtain the value for the sum. If that is given, then equation 2 will be used. But if you're just given the number of terms, the first term and the common difference, you can't obtain the sum from equation 1 over here. To check for the application of all these things I've just said, let us consider an example. We're asked to find the sum of the first 25th terms of the sequence 11, 15, 19, 23, and 27. When you have a problem like this, the first thing you have to do is to check, is this problem or is this sequence an arithmetic operation, or is it not an arithmetic progression? Okay, so let us check. Remember, to check for the particular arithmetic progression, we have to consider the common difference. And we said that the common difference is d is equal to t2 minus t1. It must be equal to t3 minus t2, which must be equal to t4 minus t3, which must be equal to t5 minus t4. So let us check if they are the same. D will be equal to 15 minus 11, which is equal to 19 minus 15, equals 23 minus 19, equals 27 minus 23. So let us check. D will be equal to 4, equal to 4, equal to 4, then equal to 4. Since all of them have the same value, then we can say that the sequence here is an arithmetic progression sequence, or it's an arithmetic sequence. Okay, now since that is said, we would have to look for the sum of the 25th term using the equation over here. Sn is equal to n over 2 into 2a plus n minus 1d. And in this case, n is equal to 25. So S25 will be equal to 25 over 2 into brackets 2 times a is equal to 11. A is the first term, which is equal to 11, and then we have 11 plus n minus 1d is 24d. So 24 times d, the common difference is 4. So if we compute this, we have that S25 is equal to 25 over 2 into 22 plus 24 times 4 is going to give us 96. So this will be equal to 25 over 2 times 118. Divide this, we have 59. Therefore, S25 is equal to 25 times 59, which is equal to 1,475. So the sum of the first 25 times of this sequence is equal to 1475. The implication of this is, if you keep adding 4 to this sequence, if we continue, the next one will give us 31, the next one will give us 4 plus 31 is 35, and so on and so forth. If we continue till the 25th term, okay, let's say the 25th term is x, and we decide to add all of them together, that is 11 plus 15 plus 19 plus 23 plus 27 plus 31 plus 35 plus blah 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 till you get to plus the 25th term. If you add everything together, it is going to give us 1447. If you doubt me, just take your time to list out all the 25 times of this particular sequence and begin to add them one after the other. When you get to the 25th term, then your answer should be equal to 1475. If it is not equal to 1475, then you are wrong at some point. So this formula is actually used to approximate the long processes involved in adding the terms in a particular sequence. So this is where we draw the curtain for this class. If you have questions, kindly drop them on the platform, as we'll always be here to attend to your worries.